Hey everyone, we're going to do an investigation about the Pythagorean Theorem today. We'll learn what it's used for, what the point of it is, how it works, and try some problems out. So if we look through these bullet points, it says the Pythagorean Theorem allows us to find the third side of a right triangle. Keywords, has to be a right triangle, if we know two of the triangle side lengths. So it doesn't matter which two sides of the triangle you know, you could use the Pythagorean theorem to find the third one. The reason it's called the Pythagorean theorem is it's named after this guy named Pythagoras. You could read more about him. He was interested in a lot of things beyond just math, but we know him best, I believe, as the creator of the Pythagorean theorem. So the second bullet point, did you know that the sides of a right triangle have special names? The two sides that form the right angle are called the legs and are noted as sides A and B. So I kind of drew that out of my picture. You could see where the right angle is right here. And the two sides that touch the right angle, that connect at that right angle, would be the two legs. It doesn't matter which one you call side A and which one you call side B. You can interchange those two names. Those are the legs. The last bullet point says the side across from the right angle is always the longest side of the right triangle. And that could be an important clue in problems that you see, because sometimes they don't tell you which sides are the legs and which sides are the hypotenuse, but you have to just remember the longest one is going to be the hypotenuse. So this side is called the hypotenuse, and it's noted as side C. The hypotenuse has to be side C. The legs are A and B, but it doesn't matter which one's A and which one's B. Hypotenuse has to be side C. C has to be longer. So I'm going to have you guys start with part 1 of this activity, which basically finishes up this page. Pause the video, try to do the activity, come back when you're ready for me to go over it. All right, so hopefully you're ready for me to go over it. If we take a look at this picture at the bottom, number 1 says to count how long each leg of the triangle is. So for A, I like to count the spaces between the lines. I think that's the easiest way to count something like this. A is 4 units. B is 1, 2, 3 units. Step 2, draw a square that is attached to leg A and a square that is attached to leg B. The square for the hypotenuse, which is C, is already done for you. Well, I know that if A has a side length of 4, that has to be the other side length of the square as well. So here's my square for A. And for B, that has a side length of 3. So the square has to look like this. And they've already done the square for side C for us. Find the area of each of your new squares. The square of side A is, well, it's a 4 by 4 square. So to find the area, just do 4 times 4, 16 square units. Side B is a 3 by 3 square, so 3 times 3 is 9 units. And then it says to find the sum of these two square areas. So 16 plus 9 is 25. Now, what they're saying in step 5 is that we can't exactly count the side lengths of square C like that because they're on a diagonal. So they've taken this exact triangle and the exact square and rotated it so it's easy for us to count. So let's see. 1, 2, 3, 4, 5. It's a 5 by 5. And it says, how do the area of the side A and B squares compare to the area of side C squares? Well, side C square, the area can be found by 5 by 5, which is 25. And it's actually the same. So when we found the area of square A, so that would be A squared, that's the 4 by 4 portion. And when we found the area of side B, that was B squared, that's the 3 by 3 portion. and then we added them up to get 25, that was actually equal to the side C square, which was 5 by 5. So when we added up the area of the A square plus the B square, we got the area of the C square. And that is actually the Pythagorean theorem right there. A squared plus B squared equals C squared. So that's something that we're going to be using in the future. Let's take a look at part 2. Try to do all of part 2 now. Pause the video, come back when you're ready to go over it. All right, hopefully you are ready to go over this. So repeat the process from the last problem. Looking back at the instructions from the last problem, the first step was to count how long each of the sides was. So side A, let's see, is 12 spaces. Side B is 5 spaces, so 12 units and 5 units. And when I draw that square out, so I know that side A is already 12 long, so I need to count 12 out to the side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hopefully I didn't miscount, but we'll just assume that that is correct. So the area of that one would be 12 times 12, which is 144. Side B, I need a 5 by 5 square because B is 5 long. 1, 2, 3, 4, 5. All right. And I know that 5 times 5 is 25, so that's the area of that square. And then C, I can't count on the diagonal, but I can count it over on the right side when they rotated it. C ends up being a side length of 13. So 13 times 13 is 169. So what they want us to do is compare what these areas are when I add up the two legs areas. So when I did square A plus square B, I want to see if it still is equal to the area of square C. Square A was 144, square B was 25, square C was 169. And yeah, that is equal. It checks out. So the conclusion that we can draw is basically the same conclusion that we drew in the last page. If we take the side length of A and square it. So that would be like saying take 12 and square it. So there's 12 squared it. And then we take the side length of B and square it. So that's like taking 5 and squaring it. And we add those two up. We should be able to find the side length of C and square the answer to C squared. So that would be 13 squared. So again, we get the same conclusion. So the reason that we're taking the areas of these squares is because that's just a great way to visualize squaring the number. That's the whole point of creating these squares and finding their areas. So it says explain how the diagrams from part 1 and 2 demonstrate the Pythagorean theorem. So what it's saying here, and you could write this out in different words, is basically the idea of you can add up the squares from sides A and B. You can add up the squares from sides A and B, and it equals the area of the square from side C. And it equals the area, the space of the square from side C. How might you use the Pythagorean theorem to find a leg length when given the length of the triangle's hypotenuse in one leg? So that's kind of asking us to work backwards. The regular, most standard, basic way to use the Pythagorean theorem would be if you know side A and you square it, and you know side B and you square it, you can use that to find C squared and then take the square root. But they want us to think backwards. So what if we don't know A? What if we only know B and C? Well, we can just solve an algebraic equation then. So let's take a look at how it looks in both cases. So let's say that I have two different triangles. So here's one right triangle, and let's say I just want to pick easy numbers to use. Maybe I'll use 6 and 8, and then here's my x. And as you can see, x is across from the right angle, so x has to be side C. That's side C. Doesn't matter which of the other two are A and B. I could say that 8 is A, or I can say that 8 is B. I'll just go like that. So this would be kind of like the straightforward way of using the Pythagorean theorem. So I would say a squared plus b squared equals c squared. I would substitute in 6 squared plus 8 squared, and I would get c squared. 6 squared is 36. 8 squared is 64. That equals 100. So if 100 is equal to c squared, but I want c, I have to take the square root of both sides. And I get that c equals 10. So that would be like the straightforward way of using the Pythagorean theorem. But now, what if I just kind of mix up the information that I was given? So here's my right angle. Maybe I don't know the 8 this time. I'm going to use the same numbers just to show how it compares. So 6, I'm going to just call side A again, but I could have called it side B. X will be my B. 10 has to be my C because it's diagonal from the right angle. So this time, I have the same formula. A squared plus B squared equals C squared. You always start with the same formula. A squared is 6 squared. B squared, I do not know. So you can keep it as B squared, or you could write X squared. Doesn't really matter. C squared would be 10 squared. So I would solve what I can. I would get 36 plus B squared equals 100. Solve it like an algebraic equation. Subtract 36 from both sides. I get B squared equals 64. Take the square root of both sides, and I get B equals 8. And both of my triangles match, because based on the Pythagorean theorem, there's only one right triangle that's going to work this way with this specific set of numbers. So that answers question 9. How could you find a leg instead of finding the hypotenuse? So this is kind of like the basic way to solve it, finding the hypotenuse. That's like the more common, simpler way. But we are not common and simple, so